Hello friends, welcome back. In the previous tutorial, we have created an array of devices and we know that this array is going to hold 5 instances of device class, and we also called switch on method on each device. What we are going to do in this tutorial means we are going to understand creating array of instances in more detail and get more information. Here we have a class called device and it has one method switch on, which is virtual method, which we can override in the derived classes if we want. What I want, whenever I create a device, I can create a device something like this: device 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 0 is equal to new device bracket. You can see that the class is having implicitly a default constructor. We know that even though we do not write any constructor, by default we will be having a default constructor which is going to be a parameterless constructor which looks something like this, right? Now what I want, whenever I create a new device, I want user to send an ID. I want every device should have an ID. We know that every device is going to have a unique ID. So here every device should have an ID, an integer number I have to give to that ID. Whenever I create a device, I do not want user to simply create a device. He must and should give an ID. I want every device must and should have an ID. So what I do, I create a parameterized constructor, public device, it takes an ID, bracket, opening brace, closing brace, and what it does, it simply sets this dot ID is equals to ID that we give. Now here you can see that this time if I try to create a device, it asks for an ID. We know that if I create explicitly any constructor, then we will not be having the parameterless constructor, or the implicit default constructor will not be available. I cannot create a device like this. If I save and come back, we get the error message. The error is the type device does not contain a constructor that takes 0 arguments. Here this constructor takes 1 argument. There is no constructor which takes 0 argument. If you explicitly write any constructor, then we should remember that this implicit parameterless constructor is not going to be available anymore. So we created this. Now if I want to create devices, I can create devices. So I have to pass the ID. I can create any number of devices, right? I can say device 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 1 is equal to new device. It creates another device. I can create one more device if I want. device device 2 is equal to new device 2. Device 3 is equal to new device. Similarly, I can create another device 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 4 is equal to new device of 4, bracket close, semicolon. Like this I can create any number of devices, and we can call the switch on method on each device, device device 0 dot switch on. I can call switch on method on device 1 dot switch on. I can call device device 2 dot switch on. I can call device 3 dot switch on. I can access the ID also. You can see that device device 4 dot, you can see I can get the ID, I can get the switch on method. We have other inherited methods also from the object class, like toString, getType, getHashCode, and equals. Here we need a switch on method to be called, and this time if I save and run, we get device switched on, device switched on, device switched on, device switched on, device switched on. 5 times we get the output on the screen, device switched on. If I run the code, you can see that device switched on, device switched on, device switched on, device switched on, device switched on. 5 times we are getting the output. As now we have IDs for each device, we will add, instead of saying device switched on, device switched on, device switched on, is it possible to say device 0 switched on? device 1 switched on, device 2 switched on. How do we do that? As we know that every device has an ID, I can write something like this: device double quotation plus this dot ID plus double quotation. So here what happens, we know that it displays device, then it gives a space, then it displays the ID, then a space, then switched on. Let's save and come back and check out what happens now. If I run the code, you can see that it is displaying device 0 switched on, device 1 switched on, device 2 switched on, device 3 switched on, device 4 switched on. So you people need to understand, because you need to think logically. Now we have a device class which is going to be a base class for other classes, and I can create here 100 devices. I can create more than 100 devices. I can create any number of devices. As you can see, this is going to be a redundancy. We are creating again and again this code. We are just copying and pasting it and changing the ID in every place. Instead of that, what we are going to do, we are going to create an array which can hold the device references. So for that, we are going to create a device array, DEVICE, device, gonna be an array with the name devices is equal to new device array, and we can mention how many devices that I want to store in that array. Then we can use a for loop for integer I is equal to 0, I is less than devices, or devices dot length I plus plus, bracket close, opening brace, closing brace. So this for loop is now going to be executed 5 times. Now what we can do, we can say here, instead of saying like this, let me copy these 2 lines and paste and explain you. I just say Control X and Control V. Here we are going to say, instead of creating a new device here, I can say devices of I is equal to new device. Instead of passing a constant value, I pass the I there. Similarly here, if I have to switch on any device, I say devices of I dot switched on. Now I can delete these things. If we reduce the number of lines of code, I can create 100 or more than 100 arrays, devices also very easily now. This works same. If I save and come back and run the code, we get the output as device 0 switched on, device 1 switched on, device 2 switched on, device 3 switched on, device 0 switched on, device 1 switched on, device 2, device 3, device 4. All devices are now switched on. Very simple, right friends? I put a breakpoint over here and attach a debugger. We know what happens actually. Already we know. Still, I just run and show you. You can see that first we have devices which is filled with a null. I just step into. Here we created the device array which is having 0 to 4 index, and all are filled with null by default, because still we have not put any reference of a new device created. Then we are having the for loop. We move inside. As I is equal to 0, devices of 0 is going to hold the reference of a new device, and devices array is actually going to hold the reference. Each index you can think like a separate variable. Device 0, device 1, device 2, device 3, device 4. Each is a separate variable. Each is of type device. So each reference variable can hold an instance of a device. That is the reason we are creating a new device with an index 0, with an ID 0, and we are putting that reference in the devices of 0 index or the memory location. I just say step into. This time you can see where it goes. It goes to the devices constructor. It sets this dot ID equals to ID and comes back. And now devices of 0 is filled with the device. You can see that devices of 0 is of type device. And if I open this, you can see that it has a ID with the value 0. And we have a switch on method in every device, so it calls the devices of 0 switch on. It goes to the switch on method, you can see that, and it displays device. This dot id is 0, you can see that it says device 0 switched on. And step over, we come back. Now I is going to become 1. 1 is less than 5 is true, so it goes inside. And devices of 1 is going to hold the new instance of device which has the id 1. You can see that it goes to the constructor, it set this dot id is equal to id and comes back, and we have devices of 1 which is of type device, and if I open that, it has the id 1. Then after that it calls the switch on method on that devices of 1. As devices 1 has the id 1, you can see that id is 1, so it displays device 1 switched on. Step over, come back. Then I is going to become 2. 2 is less than 5 is true. It goes and creates a new device, puts its reference in the devices of 2. I just say step over. You can see that we have a devices of 2 with the id 2. Similarly, I step over, it displays the device 2 switched on. Then I is going to become 3. 3 is less than 5 is true. I go inside, I create a new device and put that in a devices of 3. You can see that devices of 3 created with the id 3, and it displays device 3 switched on. Step over. Now I is going to become 4. 4 is less than 5 is true. It comes inside, it creates a new device with the id 4, puts in devices of 4. Step over, and it displays device 4 switched on. You can see here devices of 4 created with the id 4. Now the id is going to be, I is going to become 5. 5 is less than 5 is false, so the control comes out. This is how the code works. If you want to see the memory representation, it looks something like this. We have the devices array. It is of type device, D-E-V-I-C-E, device array, and it can hold the array of devices, the reference to array of devices. So here we have an array created. Each box that you see is of type device, and this complete array reference is #10 that we kept in this devices array, and it is pointing to this. 0, 1, 2, 3, 4 is the index of this devices array. Each can hold one instance of device. Here you can see that every box that you see here is one instance of the device that we created. So whenever we create a new device, we are giving an index. The first id is 0, next id is 1, you can see that. The next id is 2, the next id is 3, the next id is 4. When we say devices of 0 switch on, then what happens? It displays device. This dot id is 0, so device 0 switched on, it will display on the screen. This is how the code works, guys. This is how it looks. You can imagine something like this. I hope you guys are understanding. It's a very simple method. Next, we proceed further and create a specific device. I create a class called TV, and it is going to be of type device, D-E-V-I-C-E, inherits from the device. Now here what happens, we need to understand, guys, very important part. I just remove this and I comment this complete part. We don't have any code to execute now. I just save this much. If I write like this, we know that the ID is going to inherit to the derived class TV, right? And it inherits the switch on method also to the derived class as a virtual method. If I come back to Unity, we are going to get an error message. We understand what is that error message. I clear this. You can see that I got an error message that the type device does not contain a constructor that takes a 0 argument. What is that? Device does not contain a constructor that takes a 0 argument. What is the meaning of that? Let us understand. We know that the TV is going to have its own implicit default constructor. We know that, right? We will be having a public TV constructor, implicitly a default constructor, a parameterized constructor is there. We also know that every constructor is going to have in front of it colon base bracket bracket. We know that it calls the base class constructor, but you can see that this base constructor is calling the default constructor, implicitly available default constructor device. Understanding? This device, this base call is calling the implicitly available default constructor, which is a parameterless constructor. As we have created a parameterized constructor and it is trying to call the implicit default constructor, that is not available. That is the reason system is telling that the type device does not contain a constructor that takes a 0 argument. So whenever you call the base class constructor now, explicitly you should send the ID to it, then only it runs further. Let's take an example that if I give 0 there, just one integer value I am giving, if I save and come back, that error will go away. You can see that the error has gone. Now here what I do means, of course we have the ID variable inherited to the derived class, right? I can make it protected so that it can be accessible only within the same class and its derived class. I should not be able to access in some other block that ID, so I make it protected. Then I do not want user to create a TV like this. I must and should tell to user to give an ID to that TV, whichever TV you create. So here also I create an integer variable called as ID. That ID is going to be taken, and you can see that this body is not going to have any code because we don't have any variable to set. I send that ID to the base class constructor. You can see that we send this ID, that ID we take, and we send that to upper class. You can see I just say here, if I create a TV variable, TV0 is equal to new TV. If I put a bracket, you can see that we don't have a default parameterless constructor. The reason is we created an explicit constructor which takes one parameter, and I can give an ID to it like 0 if I give. Then what happens, you should understand here. When this line will get executed, we know that the new keyword is going to create a new TV and it calls this constructor TV. It sends the value 0 to it, ID will be having the 0. We know that before executing this body, it goes to the base class constructor which takes one integer value and it moves from here to this constructor and it sends the ID value that we have given, 0, will be sent here. Then that 0 will be assigned to this dot ID. Understanding? Then the control comes back. Now how it looks, if I have to explain you guys, I just take another page. I want to make you clear that how it works. Here what I do, I just copy this complete code from here and come back to the page, paste it, and we know that when we create, this is going to be an instance of the TV. This complete block is going to be an instance of the TV. This part is the instance of the base class and this part is the instance of the derived class. And here we know that this complete instance block is of type TV, which has an integer variable ID. That is, at present you can think like we have one memory location ID which is not yet initialized. Let's take it is 0. By default it is going to be initialized to 0. And this instance ID is #1. And of course that is what happens when you say here equal to new keyword. Then when you say TV constructor, if you call, it goes to this TV constructor, and that you can see that the control goes to this place, and here you have ID we have sent 0. Before executing its body, it calls the base class constructor and it sends the ID that we have sent 0, and that 0 will be stored in this ID variable, and that 0 will be assigned to this dot ID. So this dot ID is going to be 0, it will be initialized, and then the control comes back. Then this body will be executed. And after that, what happens? The control will just come back to this place, and the left hand side we have a reference variable TV0. So we will be having a TV0 reference variable, which is going to be filled by the #1, and once you store the address, it starts pointing to this memory block. You can use this TV0 to see which device switched on. You can call TV0 switch on method, because this public method is also inherited in this instance, right friends? So if I want, I can call here TV0.switch on bracket. If I save and run, we do know that what happens when I say TV switch on. It goes to the TV base class device, and it checks that whether there is a switch on method. Yes. Is it a virtual? Yes, it is virtual. And it goes to its derived class and checks that whether there is a switch on method overridden. No. As it is not overridden, it will execute this body, and it displays device. This .id is 0, so it displays device 0 switched on the screen. That's what happens. If I come back, we are not going to have any error message. And if I run the code, you can see that we got device 0 switched on. If I want TV0 switched on, I have to override it in the derived class. So I copy this and paste it down. Here I have to tell override, override. Override. Instead of device, I say here TV. This time we are going to get TV0 switched on. If I save and come back and run the code, you can see that we got TV0 switched on. So this is how you can use the base keyword, and you can override the methods to get the desired result. Understanding? You can see here when I say TV0 switched on, we know that it moved to the base class and it checked whether there is a switch on method, and the switch on method is a virtual. It moved to the derived class instance. It checked whether there is a switch on method overridden. No, as it is not overridden, it executes this method. It displays device. Instead of device, we have a overridden method. As we have a overridden method below also, I can copy this and paste it down here. We have that overridden method. This is not a virtual in the derived class. It is override. It has a keyword override. So as switch on method is overridden, it executes this body, not this body. So instead of device, here we have a TV written. Here we have TV written. So it displays TV. This .id is 0. TV0 switched on will be executed when I say TV0 switched on. That is what happening over here, guys. Understanding? So now we can be able to create any number of TVs. As we have this array, devices array, each index or the memory in the devices array is of type device, and we know that base class reference can point to the derived class instances without any problem. So instead of creating a new device, I can create the new TV, and I can say devices of I switch on. Like this I can call. If I save and run, what happens here? It creates 5 TVs and puts that in the devices array, and it calls on each TV switch on method. If I save and come back and run the code, you can see that we got TV0 switched on, TV1 switched on, TV2 switched on, TV3 switched on, TV4 switched on. We understand how this code is working in the next tutorial. For this tutorial, this much is enough, guys. Please try to understand what I am explaining. Understand this video, put the breakpoint, you know how the code works, understand step by step. So thank you, guys. Thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing.